And welcome to this video on functions aimed at GCSE higher tier math students. So in this video, we'll be looking at evaluating functions, solving equations that contain functions, and beginning to look at composite functions. It might be that you know what these things are, in which case what I'd encourage you to do is pause the video at the beginning of each slide and give the questions a go, and then just check against the solution. It might be that this means absolutely nothing to you, in which case feel free to watch as much as you like. As soon as you do know what you're doing, then I'd encourage you to pause the video and give things a go in your own time before watching the rest of the solution. So we've got two functions here. At the top, we've got the f of x. Well, that f makes sense, f for function. And the f of x is just 2x plus 1. So it takes an x value, doubles it, and then adds 1 to it. We've then got a second function, the g of x. Well, we've already used f, so we have to use g. And this one takes an input, multiplies it by 3, and takes that amount away from 10. So what a function does is we introduce them as function machines. So if I have the f of x as this function, we take an input, we put it in, and we get an output. Okay, it takes an x value, we put it into the function machine, and you get out twice that value, add 1. So if I put in the value of 1, it doubles it and adds 1, so double 1 is 2, add 1 is 3. Okay, for this question I need to find the f of 3, so I'm taking the input of 3, we're going to double it and add 1 to get 7. So that's what we're doing, but let's look at it in algebraic notation. So if my function is f of x is 2x plus 1, what I'm finding is the f of 3, okay, and I'm going to use a different colour for that. So between these two lines, what I've done is I've replaced x with 3. That means on the right hand side of the equation, I'm going to replace the x with 3. So instead of an x here, I'm going to replace it with 3 plus 1. Okay, so the f of 3 is 2 times 3, which is 6, plus 1, which is 7. Okay, if you stick to that principle, then everything to do with functions is not so bad. So let's look at the second one. So we're looking now at finding the g of 2x. So the g of x is 10 take away 3x. Now I'm finding the g of 2x. And again, let's write that one in red. So the right hand side of this equation is going to be exactly the same, 10 minus 3, but instead of x, I'm going to write 2x. So let's work that out. The g of 2x is 10, take away, expand the bracket, 3 times 2 is 6x. So it's 10 minus 6x. Okay, we can now solve some equations using this. So the first task is, so we've got the same f and g at the top. I would need to solve, when is this function equal to 15? So when is the f of x equal to 15? So what input do I need to have to get 15 as my output? So what we're going to do on the left hand side, instead of writing the f of x, we're going to write down what the f of x is. That's 2x plus 1 equals 15. And now we've got a two-step linear equation that we can solve. And we do that by subtracting 1 from both sides. So we get 2x on the left-hand side equals 14, and then half both sides to get x equals 7. Second question on this slide then, I'm solving f of x equal to the g of x. So I want these two functions to have the same value, and we're looking for the value of x that will make both of those functions equal. So on the left hand side, instead of writing f of x, I'll write down what the f of x is. It's 2x plus 1. On the right hand side, I'll write down what the g of x is. It's 10 minus 3x. And now we've got an equation to solve. So my principles for solving something like this, I want all of my x's on one side and all of the constants, the numbers on the other. So I'm going to choose the smaller number of x's. Well, I've got 2x and negative 3x. Well, negative 3x is less, and it's a negative value, so I'm going to deal with that. The way we get rid of that from the right hand side is to add 3x to both sides. So on the left hand side, I have 5x plus 1 equals 10. And then we solve like normal, take away 1 from both sides, 5x equals 9. So x is 9/5, which is 1.8. You can leave it as 9/5 though. So what that is the value of x that makes both of these functions equal. Okay, lastly, we'll look briefly at composite functions. So the way a composite function works is they work from the inside out. Okay, so the f, g of 1, they work like Russian dolls. So we work for the innermost one first. So we're finding the f of the g of 1. So what we do is work from the inside out. We're going to first of all work out what the g of 1 is. So g of 1 is 10 minus 3 lots of 1. So it's 10 minus 3, 7. And now that output from g of 1 becomes the new input. Okay, so that becomes the input into f. So we're now going to work out the f of 7. Okay, so the output becomes the input. So the output becomes the new input. So we now need to work out the f of 7, which would be 2 lots of 7 plus 1. So that's 14 plus 1, which is 15. Looking at this next question then, the g f of x. So this is the reverse. So the first thing I'm going to do is write down the f of x. Okay, so let's draw a border between these. So the f of x is 2x plus 1. And just like before, this output, well, you notice that I've just stated f of x. That output becomes my new input. Okay, so this output becomes my input into g. So I'm now going to work out the g of 2x plus 1. So just like we've done every time before, we're going to take the function and change x for 2x plus 1. So this will be 10 take away 3 lots of 2x plus 1. Let's expand that bracket out. So 10 take away 3 times 2 is 6x. Negative 3 times positive 1 is negative 3. Simplify, we get 7 take away 6x. Okay, hope you found that useful. I would check out resources you know are available to you to work on a bit more functions. Thanks for watching. Goodbye.